Before watching this video, I assume that you have watched the video which was the first video in this playlist, which was about building a first basic application. If you have not done that, please go and watch that video, because this is continuation of that video. Now the people who have watched that video and come here, you would agree that what we did in the previous video was kind of childish. I mean, it was meaningless. We had created a get endpoint which just returned some hard-coded value. And as we understand that, we know that a system like that is useless. So eventually you have to store the data somewhere. And to store the data somewhere, we have to have some persistent storage. And in our case, we are going to use MySQL to basically store the data. Now, before we can use MySQL, let's configure it. In my introduction video, I had asked about have MySQL installed. If you don't have MySQL installed, I think now is the time to pause this video and install. You can have install the MySQL on your machine. You can have a local installation of MySQL, or you could have a MySQL installation on cloud. The cloud would probably be a little bit slower, so it would be better if you have a local installation, and anyway it is free, and you don't need a very high-end machine to do that. Once you have MySQL installed, I hope that you know the password for the root user. If you have set it, most of the time it is not set, so it probably would be nothing. And now let's start to configure this particular database. So to do that, open a terminal, and within a terminal we basically want to configure the database. So the first thing that we are going to do is run this command MySQL -u root, which will grant us the root access into MySQL database. Now let's create a database for ourselves. I will call it video tutorial. You can call it whatever you want. So I create a database called video tutorial. After creating the database, we have to create a user. So I create a user, again, video tutorial. Now we normally create two users. One would be video tutorial at localhost, and other will be video tutorial at %. And the command for that is create user video tutorial at localhost, identified by whatever we give after identified by is the password. So remember that. In my case, I am just giving it video tutorial 123. Now we create another user. Now we have created two users, and now we have to grant access to these users to our database. So now we run a command for that. Now we exit from MySQL command line and just check it once. So we check whether the database that we have created works. And we can connect. So the database clearly works. So our database setup is done. Now we go back to our Spring project and configure it to start using this database. So now let's go and configure the database that we just defined into our project. And if you see in our project, we have within the source directory, we have a resources directory, and the resources directory has a file called application.properties, and that is the file where we can define all these things. So basically there are this bunch of properties that we need to define. Let's give a comment, and first property is this called, first property is the DDL auto property. This property is used by Hibernate to decide whether it should automatically make changes to a schema or not. Now when we are developing a project, we set it to update. It means Hibernate will automatically update everything on its own, but once before you go to production, you should set it back to none, so that by mistake any schema changes are not done. There are this bunch of other properties that we need to define. So the next property is a URL, and within the URL basically we provide the details related to our database. So our database name was video tutorial, database is on localhost, and we basically also define this use SSL because it's a test setup. We allow we want to set SSL to false, and we want to allow public key retrieval. We should change it once we go to the production to the right values. The username was video tutorial, password was video tutorial, and then the driver class name is what I have given here, and the dialect is MySQL 5. So these are basically our MySQL settings, and with these we are ready to essentially go to the next step. Just to test it, we will run it once to make sure it works. So we run it, and yeah, it seems to do something. It actually hasn't thrown any error. So now we go ahead and define our, let's say we define a database entity. So let's first create a package. We call that package entities, because this is where all the database classes will be there. And within that, let's create an entity which will represent a user in our system. So let's say we call it user entity, and any class that needs to be handled by Hibernate, we need to have the entity. We need to have the entity annotation on it. So we added there. Now right now we are not basically this class is not available. It means there is a dependency that we are missing. So let's figure out what dependency we need for this to be available. Okay, so the reason it is not working is that we need to have a JPA in the Maven dependencies. So let's look for the JPA dependency. It's basically Spring boot starter data JPA. This is what we really need. So we have added this dependency, and now we can go and check out the entity again. Sometimes it takes time to refresh the Maven dependencies, so I've just manually done that. Yeah, and now we have got the Java persistence entity. So now that we have got this entity an annotation on the class, let's define what are the important things that we want them to be as part of the class. Let's say we want a ID. So we have a, let's keep a long as a ID. So there is an ID that we define. Then every user will have a full name. Then we will have a username. Then let's add a password field. and then let's add email field. So these are the fields in the class. Now every Hibernate entity needs to have a primary key, so that is defined by ID annotation. So here we say ID, and we also say that we don't want to define it, it should be automatically generated. So we say strategy equal to generation type dot auto. So with this Hibernate will automatically create the ID field. Now as we did in the previous thing, we go and generate all the getters and setters for this. So we can go to generate getters and setters, and we have the class. So this is our entity that is defined. Now along with the entity, we also needs to define something called a repository. So let's create another package where we will keep all the repositories. And we basically define a user repository. Now the user repository needs to extend CRUD repository, and it is a generic class where the first argument is the data type, the entity type. So in our case it is user entity, and the second is the primary key type, which is long in our case. And this should not be a class, this should be an interface. Now with this we get the benefit of using a CRUD repository, that it provides us some standard operations on every table. So for example, if you click on it, you automatically get save all, find by ID, exist by ID, find all by ID, count, delete by ID, delete all, and delete all. And these are useful things, and of course we can add our own operations, which we will see little later, but right now let's stick to this. Now that we have done that, let's define an entire. Now just to make sure that whole Hibernate is hooked up properly, because we had set DDL auto to be update, if I run it now, it should create this table automatically. So I just run it now. It ran successfully. Now let's look at MySQL and say show tables. So if you see, there is a user entity table defined, and there is a Hibernate sequence which is used by Hibernate. We can describe user entity table, and it has the field that we had defined, and you can also see the ID is defined as a primary key, and it is stored as a big int. So I think we are the Hibernate connectivity thing is working fine, and now we are ready to define an endpoint. So let's go ahead and define an endpoint. We already have the endpoint package. We go to the same package and we define a user endpoint. Now the REST is if you want to understand REST, how the REST is different than what we were doing with HTTP before REST came along. REST deals in terms of objects. So REST is more like, if the earlier web programming was procedural, REST is the object-oriented version of it. So ideally, every entity has an endpoint, and it has operations defined which are get, put, post, and patch, and delete, and remove, which is called removed. So every URL ideally should represent a class. So in our case, we have a user entity, so we define it to be the REST controller. This is very similar to the previous thing. And then request mapping, and we define a path for it. So let's call it a user. So all the user related operations will be under this. Now we know that the user endpoint would end up using user repository. So in Spring, if you really have a bean defined, because we have defined a user repository, a bean is available to us. Rather than manually creating it, we could just auto wire it. So there is an auto wired annotation, and then we can just say private user repository, user repository. Now the benefit of this is we don't have to create an instance of it. Automatically when we run our program, Spring is going to find all these beans and inject them at the right places. So when the user endpoint gets injected, it will already have a valid copy of user repository which is using the right data sources. So that is why it is important to do things this way. If we start to do it the way JDBC does, where we are defining our own database connection, etc., some things won't work properly, and there are a lot of benefits to doing things the way Spring expects us to do, which we will see in future videos, the benefit it brings to us. So now let's define an endpoint request mapping. So let's say the first endpoint is given an ID, I want to see the detail of that user. So basically this URL will look like localhost:8080/user/ the user ID. So the user ID itself is going to be a variable, and those variables are denoted by these curly braces which you see in the value field. The method, because we are going to read, the method for read is always get, and it will produce a JSON. So this we have seen already. Media type, we pick it up from springframework.http package .json value, and then this thing will return a user entity. Let's call it get user. And within get user, now we have to pass the parameter that is in the URL. To pass that parameter, because this is part of the URL, it is called path variable. So we define a path variable, and the name within the path variable is actually the name that maps to JSON. In this particular case, it doesn't matter, because we just need to make sure whatever is within the quotes in path variable is what is in the curly brace on the URL, and then we can define the type of it. Now we have this, and this is going to be very simple, because if you really see, user repository already had a find by ID method which we can just call and pass ID to it. And what does this method return? It returns an optional user entity, so we can just directly return it. The benefit of using optional is we don't have to check for null. If this method doesn't return anything, the optional will tell us that it is a null parameter. So this is one, and with this we also want to define a add method. Now creation of a new object, we just copy this method and we will modify it. Creation of a new object in JSON is generally done by post. So request method, we will change it to post. The media type is same, and we will return the new created user ID. Then we change the method name to create user, and now here we don't have a path variable, nothing is in the URL, but we will get the whole JSON. So whole JSON when we get, that is called request body. Request body is essentially the complete JSON packet that comes to us. So we annotate it with request body. We also know the type of the variable will be user entity. Let's call it user entity, and now let's see how we implement it. Now we could just do a very simple implementation where we call save on that object, but we probably want to check whether this already exists or not, because we want to make sure people are not creating duplicate users. And if you look at our user entity class, it has a full name and a username and email address. So full name could be duplicated, but we don't want to duplicate email address and the username. Now if you see the default methods that are provided by the repository, none of these methods are going to be useful here. So what we really need to do here is add our own way of querying, so that we can query the entity with a check against both the email and user ID. So to do that, we have to add a method into our repository. How do we do that? It's actually fairly simple. Let's look at how it looks. So it's an interface, so clearly there are no implementations here. First let's define how the method signature looks like. So what we really want is it should return a user entity. Of course it has to be optional, and we call it find user entity by email or username. We will never really have to use these, we never have to worry about these method names much, but we still want to make sure that they explain what we are doing here. Now this method will take two parameters. Now the parameters in these methods will be annotated by annotation param, and there we will provide the name of the parameter that we are going to use in the query that we want to run. So for example, we have first parameter is email, which is nothing but a string email. So if you see, the first email within the quotes is a parameter that matches with what will go into the query. Second email is what will go into the Java. So we have to make sure we understand that, and as a practice I just keep them same, so there is no confusion. Both are just same, but you could potentially keep them different. So now we have this method defined. Now of course we cannot write the implementation here because it's an interface, but we can provide this query annotation which will automatically generate the relevant implementation for it, which we can use. So we basically write the query that will give us this result, and what we do, select UE, which is our user entity, from user entity we alias it to UE, where UE dot email equal to colon email, and this colon email is what is within the param that we have defined, or UE dot username equal to username. So this is basically the query that we have written. The return as a user entity object where either this email is present or this username is present, and basically that's what we want to make sure, that for a new incoming request we don't have duplicate usernames or the emails. So now we go back to our user entity and we can say optional user entity, let's call it OUE, equal to user repository find UI user entity and name, where we say user entity dot get email comma user entity dot get username. Now we can check if OUE dot is present, OEU, no, let's call it OUE so that we don't have any confusion. Is present means this value exists. So in this case, we don't want to do anything. We just want to throw an exception. Now we will have to define this exception, and we will do that in a minute. Or let's call it more specific. Let's say user already exists, where we say user entity dot get email, comma user entity dot get username. If it is not present, then we can just say user repository dot save user entity, and this also returns. Now this particular method, if you see the signature, it doesn't return an optional, it returns a user entity. So we will wrap into an optional by saying that optional dot off, and that's it. So this is our save method. Now the only thing that is remaining is we have to take care of that exception. So let's write that exception. Now in Spring, there are certain exceptions which will automatically get converted to appropriate error codes, and to do that we need to have annotations on exceptions. So let's first define a package for exceptions, and let's create our exception, which is user already exists. And we add this annotation on it, response status HTTP status conflict, and within that we already know that we had email, so we can define those things. And we can define a constructor for it. Constructor also can be generated using IntelliJ, so just click on generate, say constructor. We want a constructor with both the arguments, and we also want a null constructor, the default constructor, so we have both of them there. And now we probably the exception class needs to be a type of exception. So one of the good practices is for your project have a base exception so that you can easily handle it. So let's define a base exception for ourselves. The base exception will extend the runtime exception. So now we have the base exception which extends the runtime exception. Because these are all going to be REST exceptions, we define an error code in it just in case we want to send it. And we also define a default constructor. The runtime exception automatically takes a message which we will pass it on to the super, and error code will be assigned to the error code locally. So this is our very basic representation of base exception. We also define another constructor that will take a throwable, because sometimes exceptions are wrapped in other exceptions, which is shown as a cause exception. So in that case we pass it to the base class. Similarly, there is a variant of this which takes a message as well. So it's actually in the other order, message and cause. So this is our base exception. Now let's go back to our user already exists. There we will extend the base exception, and in this we can pass, for example, we can pass it to the base class a message something like that: duplicate username or email. And the error code that we want to pass, we can just pass the conflict error code in this. So we can say so this is our exception class, and now we can just throw it from here in case of a conflict. Now one more operation that we need in this is a delete operation. So basically what we are saying is, given a user ID, we should be able to delete it. So let's copy the get operation. The path will be ID and the method will be delete, and here we can just first retrieve because we want to return it. So we can say optional user entity OUE equal to user repository dot find by ID if OUE dot is present. If it is present, then we just delete it. If it is not present, we probably want to throw another exception which says throw user does not exist. So now we have to define this and we pass ID to it. So now we have to define this particular exception. So let's go back to our user already exists. We copy it and let's call user does not exist. And rather than conflict, I think here we will say not found this will map to the HTTP error code 404, and then we can say long ID, and here we can say not found, and we can say user ID %s %d does not exist. And we remove email and username from there, we only add ID, and now we go back to our endpoint, and I think this is all right. We just have to change that, rather than get user, it should be delete user. Now all the syntax errors are gone. I think we are ready to test this. So let's bounce the server. Okay, server is up and running. Let's try to get the Postman. This is our Postman. Now as we know, our endpoint was user. So let's say we say /user/1 and we send it. It's giving us null. It should not be giving us null. If we look at raw is also null. Okay, we'll check that. Let's first call a create user, and then we will check why it is giving us null. So to create, we need to do a post on user, and the body here has to be, we call it raw, and the type we set it to JSON. And now what all we have is, let's say username, user1, then we say full name, user1 full name, then we say email, user1@example.com. Now let's say we post this body, and let's see what do we get. It's basically saying bad request. Let's go and look at our server. Why is it giving us bad request? It's basically giving us a parse error, so something is wrong with our JSON packet. I think this should be comma, and this should work. So if you see, this is what we got. We can pretty it so that it looks like a proper JSON. So a user got created, and if you see, the ID 1 got assigned because we had marked it as a auto generate. Now let's say we create another user, which is 2, and let's call it user2 example, and send it. We got a user2 created. Now let's say if we want to create user2 again, we send it, we get a conflict error because that user already exists. If you want to get the user 1 now, so let's call it get. It gives us the value of that user. So now the only thing that we need to debug is that why, when we take a non-existent user like 4 which doesn't exist, why is it giving us null? So let's go and check that out. So this is our method. We are going to do find by ID, with ID being 4, and it should just work. So clearly looks like there is some issue here. We are getting a null, and that is actually right, because when it returns an optional null, eventually it will translate to null. So what we really have to do is optional user entity OUE equal to, so we find by ID, and if we find it, then we return it. Otherwise we throw an exception. User does not exist, and now the user does not exist the way we had defined. It takes an ID, so I think that will work for us because we have an ID. So let's just say ID here, and we have to make it new and semicolon. Let's test this again. Now if we call it, we have to rerun it. So let's rerun it. Let's rerun the server again. So we have run it again. We go back to this. We do it again. We get a not found, which is basically the expected behavior. So with this we have a basic working REST endpoint. We can add another method which is find all. So for example, we have one get method. We can create another get method which does not take any parameter. So we get rid of the value field because there is no suffix in the thing. Get is fine. Rather than optional, now this is going to return a list because we want to show all the users, and let's call it get users. We don't have a path variable for it because there is no specific user, and we can get rid of all of this and we can just return user repository dot find all. This will give us all the users that exist. Now this returns the iterable, so rather than saying list, we can just say iterable. It doesn't matter because eventually it is going to be streamed out to a JSON anyway. So let's bounce the server again. Let's go to Postman, and now we do a get without any parameter. See, it shows us both the users. Now let's say we want to delete a particular user, so we call delete here. Let's say we want to delete 2, and then we send it. It says it is not found. So let's check what is the, let's call the previous one again, which is get without thing. It actually deleted it, but it is returning error after that. So let's find out what is wrong there. So we go to delete. And within delete, we do a find by ID. If the user is present, we delete it by ID. Yeah, so here in this particular case, if we have deleted, we should actually return this user, which we were not doing. So that was causing the problem. Now it will fix it. So we rerun the server. we go to the delete again, and let's say we delete 1, we send it, and it returns us the detail of the user that got deleted. Now the interesting thing is, if we want to create a new user now, let's say we want to create the user 1 again. Let's say this is the one that we take, this is user 1, and we send it. The interesting thing is the ID will be 3, because Hibernate runs a continuous counter, and unless you manually go and reset it, those IDs will never be used again. So even though we have deleted user 1 and 2, it still gives the ID 3, and the next user will get a ID 4 and such. So that is something that you should be aware of here if you are going to use auto-generated IDs. So we can get all the users and we get the user 1 back. So this is the first basic tutorial for how to hook up MySQL and start defining endpoints which are more meaningful. We added get, post and delete operations. We will look at other operations in the next video, because I think this is long enough. This is very long video already. So if you have watched this, subscribe to the channel, because we will be continuously adding more and more videos with more and more content. Hit the notification bell icon, share it with your friends, and thank you for watching.